Hi, it's Jan Beta, and today I'm going to refurbish this Peavey Rage 158 practice guitar amp that has a few issues. This is actually my girlfriend's Peavey practice amp that has seen better days, and yeah, it developed quite a bit of mains hum. I don't know if you can hear it through the microphone, but it hums pretty significantly. And that's independent of the volume. And also, when I turn it off, it has quite a loud pop after a while. So I guess maybe it's just worn out capacitors in this. I think this is an amplifier from the 90s. These are actually pretty highly regarded in the more punk side of the guitar playing community. Allegedly, I think the Queens of the Stone Age used these for some of their guitar tones and things like that. These don't sound bad. They are, of course, not tube amplifiers, but they have something called trans tube, which I guess is just going to be a few diodes similar to what Tube Screamer pedals do or something like that to get a bit of distortion in an otherwise pretty simple circuit probably. I think we're going to have to take this apart, take a look inside, clean it up and look at the capacitors and probably replace them. And then this has another issue, and that is that you can't actually turn this off fully. You probably can't hear it, but there's a transformer under the hood here that is humming, even if the device is turned off. So the transformer probably wiggled itself loose, so the windings are not tight anymore, and it doesn't actually turn off completely. So there's always mains power to the transformer, whether I turn the power switch on or off here. And that's not good. I would like to change that. I found schematics for this thing, but it seems to be a different model. There's a newer version of this that looks quite similar, but has different knobs and a bit of a different design. I think these are still on sale actually, so the newer variant of this you can still buy to this day, but it is a different circuit than this older one. Vintage 90s guitar amplifier. Yay! Okay, let's take it apart and have a look. Let me take a few seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They can also do CNC machining, 3D printing, sheet metal fabrication, injection molding, basically a one-stop solution for everything the tinkerer needs. I highly recommend checking out the link in the video description if you're interested in such services. Back to our rage. So this is the back of the unit. You can see the transformer here peeking out, and it has a Blue Marvel Peavey speaker in it, whatever that means. 3.2 ohms, pro performance rated. Peavey used to make some pretty good stuff, but I guess this is from an era that's not that great. Made in China, of course. These are budget amps. They're just practice amps and they work fine for that purpose. So yeah, this thing works. It just has developed quite some hum. It's pretty dusty and we're going to take it apart now, I guess. Yeah, there's just some spade connectors on the speaker I'm going to remove. And I think the whole top portion here, where the amplifier, the actual electronics are, is screwed in through this handle here. So there's two screws that probably screw down to the bottom. There's some plastic things here that might hold the whole thing in place. Let's see. The handle is definitely coming loose. Yeah, these are long screws. These go through the circuit board, I guess. Wow, okay. Pretty nice design. Yeah, it's coming loose. Okay, interesting. There are screws here as well. Yeah, there are 3 screws here as well. Let's take those out. And then the whole unit should just be removable. There it goes. There's not much in there. It's very simple and there's a lot of space in here. The power switch actually only goes to the circuit board after the transformer, as I've hinted at. So this here is always powered on. There's a ground connection. This is where the mains comes in. It's a non-detachable cable. So yeah, mains goes into this thing here and into the transformer from there directly, basically. That's not too great, actually. So yeah, let's remove the circuit board, I guess. There's a couple of screws here, and we have to remove the knobs and the nuts on the connectors from the front panel, I think. I might just replace the whole mains switch there with a main switch that actually switches the input. Yeah, very simple circuit. There's a few capacitors and they are, don't even know if they are branded at all. Suscon. Yeah, probably not the best brand of capacitors. Yeah, we are going to replace them with something better no matter what. And I'm going to give this a good wipe, probably some contact cleaner into these potentiometers and these input and output jacks. Yeah, don't know about the switch situation here, but we're going to figure something out. Let's remove the circuit board at first. So this is detachable, that's nice actually. There's also a fuse. So we have some longer screws in this heatsink thing here. These nuts here on the front have to go, and all the knobs, that these can probably just be pulled off. Yep, they're not even screwed through. And then these are just plastic. This is not very expensive. Or at least it's not very expensively made. I don't know how much these go for, but yeah, not super high quality, as you can probably tell. So this should now be loose. Yep, it appears to be. We are going to desolder our switch here, I think, to be able to take this whole thing out. And we are free! Set this aside. And we're going to replace some capacitors on here. Yeah, these are hot glued down, but that shouldn't be much of an issue, I guess. I'm just going to take pictures of the circuit board so we don't get any caps in the wrong polarity, because I don't think... Oh yes, there are markers on the board for the polarity actually. And they appear to be correct. Most of them are 22 microfarad, the small ones. And the big ones are 1000 microfarad. And the size of these doesn't really matter because there's a lot of room, as you can see. So should be good, I guess, with whatever I have in my parts bin. Let's fire up the desoldering station and get some capacitors out. I've done this many times, so I'm not going to go into much detail. You just want to put all the capacitors in the correct polarity, and you want to use the correct values. At least the microfarads value should be absolutely the same. You can go higher voltage than the original ones, but I prefer not to go much higher because the capabilities change a bit, the specs. Yeah, we're going to remove these capacitors. I'm going to remove these 1000 microfarad ones at first. This is just a single-sided circuit board, so it should not be too complicated to desolder these. Yeah, it doesn't help that these are glued down. Maybe I'll just remove the glue first. Here's a neat trick for hot glue like this. Use some alcohol, and that should pretty much loosen it up. Yeah, there we go. Instantly better. Okay. Okay, that's our 3 1000 microfarad ones. I'm going to replace them with some good Panasonic FC 105 degrees Celsius rated ones. That should fit the bill and are much better caps. And while I'm at it, I should also remove this one, which is a 220 microfarad one. These are going to be hot glued a bit after the fact again, I think, because it always makes sense in a device that has a speaker in there and is vibrating. I think the other ones might just all be 22 microfarads. Yep. So we're just going to replace all of these now. So there we go, all new capacitors in there. That wasn't too bad. As I said, it's a single-sided circuit board, so it wasn't too hard to solder on it. I think I'm going to take this switch out of the equation altogether and make it a better main switch that actually switches both phases, and I'm going to wire it up to switch the thing before the transformer. So we're going to have a proper main switch in this. I don't see why that would make a difference, really. Just probably going to take out one of these and then wire this up to permanently be on, basically. This is where the switch contacts close, really. Just going to wire this to permanently on and wire the mains input to this and yeah, switch it properly before the transformer, so the transformer is off. Probably going to drill a hole into the front panel here and replace the old power switch. Yeah, could work. It could work. I really like these round power switches. It's going to deface this a bit, but I think that's fine. I really don't know why they switched this after the transformer. Probably, yeah, I don't know, really. If you know, maybe there's some kind of spike or something. You switch this on, but this is just a transformer. Don't know what switching this completely off would change, really. Nothing much to lose, I guess. Let's do that. And then for the transformer hum, I have another idea that we're going to make happen. Yeah, this is pretty neatly wired up here on this little daughter PCB, so it shouldn't be too difficult to wire it up to a switch, really. Also probably worth checking the diodes, the rectifier diodes on this. These little ones here. Maybe one of them gave up the ghost, which would also explain more hum than necessary. So I'm just going to use diode testing mode here on my multimeter. And that should give me an indication. Yep, looking good. Yep. Yeah, they are all good. And yeah, our trans tube is probably 2 of these diodes here. 2 smaller diodes. That's all that is. Like probably similar to a tube screamer, as I said. There's no tube in here, clearly. That all seems hunky-dory. I'm just going to wire this up so it is permanently on. So I'm going to remove one of these wires. Yeah. Use this one to close the connection permanently, I guess. This was just wired directly to the circuit board, so nothing much to lose. So I'm just going to stick this through here. and solder it in place. So now it's permanently on, and our original switch is completely out of the equation. And we're going to make our mains switchable in the next step, which probably is going to require me to drill a hole. So this power switch has to come out of this, and it's just one of those click-in ones. So this should technically, yep, just move, depressing these tabs here. There we go. It's not the best quality. 2 amps, 250 volts. So we got our old switch out. A new switch should fit like this. We just need to make this hole a round hole, and it should fit fine. To the step drill! Think my battery might be dying. Yup, battery's dead. Going to have to charge the battery, but in theory this should work fine. So while we wait for the drill battery to charge, I'm just going to try to remove the transformer to treat that. Yeah, there's 2 screws that hold the transformer in place. So we're going to desolder these contacts here, I think. Or the wires, rather. So these are going to be connected to our switch. We can totally use this little daughter circuit board here. It's actually a pretty nice construction. So the transformer just has 2 screws that are kind of Loctited in place. And it could use some rubber washers or something. Let's see what I have in my parts bin. These were pretty loose too, so probably that didn't help the transformer hum. So this should technically just come out. Yep. I have this sealant for circuit boards that is a highly insulating, transparent, protective lacquer for circuit boards, and that actually is a nice trick in case your transformer starts humming because the windings came loose over the years, which is pretty common actually. Sometimes you have screws on these that you can just tighten. This one is just clipped together, so not much we can do on that account. But there are some holes here that I can probably get some lacquer in. The windings are visible here, so maybe we can just kind of flood this with this stuff. And most of the times, after letting that dry, it's going to make the hum at least a bit more bearable. So that's what I usually do with these. So I have an air filter running here because this stuff is lacquer. I don't want to inhale too much of that. I'm just going to go in. You could take this apart, which would probably be the best idea. But usually, if you do it like this, this at least helps to some extent. Yeah, that's all that's to it. Now we're just going to let this dry for some hours, probably.
Later that same evening.
Okay, my battery is recharged. Let's try that again, shall we? And I think that's it already. Yep, doesn't look too bad. So yeah, this is what it looks like now. Should be fine. And this is actually a double pole, double throw. So we can switch both live and neutral, which is the way to go, I think. Yeah, I'm going to clean up the metal flakes with my vacuum cleaner and a brush. And then we're going to continue this journey. Just want to see if my circuit board still fits in here with the new switch in there. Yeah, that should be fine, I think. Yeah, it just fits. I think that's going to do. We just have to insulate everything nicely here. I'm going to solder directly to this, our new wiring. So what we need to do is to wire these things through here. These are the mains inputs, and then wire them through here, both of these. So we need some extra wire, and then to the transformer from here. Mains goes in here and comes out to the switch. Just going to route it around here, I think. Yeah, should be fine. And then we have to route it back to the transformer, of course. And I'm going to use some heat shrink tubing to insulate it nicely. So just some mains cables that I salvaged from an actual mains cable. So these are nicely in there. Routing them around to our switch. And we need some proper insulation here. So I'm going to use heat shrink tubing. And then, of course, we need some wires to the transformer from here, which are also going to be insulated. I'm just going to make the wires on the transformer a bit longer and insulate them with heat shrink tubing as well. And yeah, we're going to use some rubber washers under the transformer just to insulate it a bit more from the casing. Just found these little rubber washers. Okay, this is going to be a bit fiddly, but we're going to get there. And that's it, this one. Okay. That's nicely in there. Now for our transformer wiring. So we need these to go there. Okay. And we need more heat shrink tubing, of course. On both ends this time. This is, of course, not the approved safest way of doing this, but it's very likely going to be fine. And some more bits of heat shrink tubing for the other side. Just remember to slide the heat shrink tubing over the things before you solder them in place. So I think I want to put the circuit board in before I put the heat shrink on there, because I don't know which way this is going to have to bend to make the circuit board fit. So let's clean up the circuit board first now. So some more vacuum cleaner action. Just going to clean off the dust from these potentiometers. They are all closed potentiometers as far as I can see. But I'm still going to put a bit of contact cleaner in there, just so this is clean. But first, let's remove the dust. And then we are going to have to put some hot glue back on here as well. That's very important, because no good project without hot glue. And also, of course, we need to clean the circuit board itself and probably put some new thermal compound on here. I'm just using alcohol and a brush to clean the circuit board, and also some alcohol to clean the thermal compound, both on here and on the other end of the heatsink. And I think this thermal compound is actually still good. I just think that we got some dust in there with our actions here. So we're not going to replace the thermal compound on that amplifier chip there. Just going to remove it from here. And yeah, there's some between the layers here as well. So on this chip, of course, and here. And this is actually still, it's not dried out or anything, so it should still do the job. But I'm still going to put some new on there, so the whole casing acts as a heatsink. Hot glue. Yeah, that should do. Okay. Thermal compound. Just going to put some standard thermal compound on this heatsink here. It's going to have to do. Some contact cleaner into all our things here while we're here. And now's the moment we've all been waiting for. Putting it back together. Just fits. Okay. Let's put some screws back in. Okay, let's do these first here. And then, of course, we're going to need some cable ties and such. And heat shrink tubing over these. So we're just going to have to tidy up the wiring a bit using some cable ties. And then we can probably put the whole thing back together. And of course, we absolutely want to plug this back in. Looking good. I like to use these neon pink cable ties so I know I was in here. But I'm also going to write that down here. Recapped and rewired. Let's put it back in the box actually and connect the speaker. Makes the most sense. Let's see if our new switch fits. Yep. It just clears the case there. Nice. Okay, let's screw it back in. So technically, this should now just work, probably, maybe. And of course we have to put the knobs back on and things, but we can do that later. Let's see what this does. Let's see if it explodes. Fingers crossed this worked. Yeah. Still hums. And it still does the little sound thing at the end there. But not as much as before. So let's put the knobs back on and call it a day, I guess. Should connect an actual guitar to this at some point. And one knob is missing. We're going to have to find a replacement knob for here, but I think I already have a perfect one. These are these half moon shaped things, so just using one that has a screw, because I don't have any of those proper ones. And it's actually pretty difficult to get these as a replacement, it seems. But this should do. Yeah, should do it. It looks the part. Let's hook up a guitar and see what it does. Okay, still works. Yeah, it still works and it sounds pretty decent actually for its size. Guitar is not quite in tune, but hey. Yeah, I think that's it for today. I hope you enjoyed this little excursion into the world of vintage or not very vintage practice guitar amps. Thank you very much for your time. Thanks for watching. Special thanks, as usual, to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page or elsewhere. The links are on my website and in the video description in case you want to give me some support and see more of these videos. That's it for today. I'm Jan Beta. Thanks for watching. See you next time. Bye.